talking about properties of powers with integer exponents today. First of all, we need to know what a power is. So it's important to know that well, let's look at an example. How about this? Now, how would you read that? Do you know how to read that? Most people would say 3 to the 5th power. Also, 3 to the 5th is fine. So what is the power? Many people will say the exponent is the power. Well, the exponent is not the power. The exponent is the exponent. Well, there is a big number and a superscript number. And we know that the 5 in this case is the exponent. So then what does that make the 3? Well, if you know it is called the base, then very good. So then what's the power? It's not another word for the exponent. In fact, both the base with the exponent is the power, and that is our definition of power. It is a base with an exponent. So is this a power? I hope you said yes. It's not written with an exponent, but without an exponent, it is that automatic exponent of 1. So one thing you're going to have to do is expand a power into a product. So right now, 3 to the 5th power is written as a power. As a product, write it as a product. So 3 to the 5th power as a product is 3 times 3 times 3 times 3 times 3. So that's written as a product. You can also use parentheses instead of the dot, especially when we're dealing with decimals, even fractions. Sometimes it's better to use parentheses. How about try this one? If you wrote -2 times -2 times -2 times -2, you are wrong. Why are you wrong? Well, let's go back and look at what the exponent is and what the base is. What is the base? Well, the base is actually 2. Not -2. How would it have been written if the base were -2? It would have had the negative in parentheses with the 2. So the base is just 2. The correct answer, so I'm going to box that so that you know. The correct answer for -2 to the 4th is -2 times 2 times 2 times 2. So be careful with that. Now, what if we had a product and we needed to write it as a power? Hopefully, if you wrote -5 cubed, that would be wrong. Now, it would give us the same answer since there's an odd exponent, but this is actually written incorrectly. You need to make sure that you put your parentheses on the -5 because -5 is the base, not just 5. Now let's move to one of our properties of powers, which is how to simplify a product of powers. So as the name suggests, we are going to multiply some powers together. Let's start out really basic. Something like 2 to the 6th times 2 to the 3rd. So what does that equal? Well, remember that 2 to the 6th is 1, 2, 3, 4, 5, 6. We're multiplying that times 1, 2, 3. So how many do you see? Hopefully you see that it is 2 to the 9th. Now in this case, do we have to have parentheses on the 2? We don't. I usually stick with the way that they write it, and if they wrote it with parentheses, I will too. But in this case, it is not necessary. Do you notice what we started with? 2 to the 6th, 2 to the 3rd, and 2 to the 9th? It is that simple. That is our rule. When we multiply powers, we add their exponents. Now don't forget that second part that I just wrote down. We are going to add the exponents of powers that have the same base. So if, for example, we had had something like 3 to the 4th times 4 to the 3rd, well, that does not equal, and students want to do this all the time, 12 to the 7th. That does not work. So you can only add the exponents of powers with the same base. Next is power of a power, which means we take a power, how about 6 to the 3rd, and we raise it to a power, like to the 4th. So 6 to the 3rd to the 4th. 6 to the 3rd power raised to the 4th power. Well, we can write this out longhand first of all. So this would be 6 cubed times 6 cubed times 6 cubed times 6 cubed. And of course, each one of those is 6 times 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 6. So how many total do we have? 6 to the 12th. So let's notice we had 3 and 4, and how do those make 12? Well, we are going to multiply the exponents. So if we had something like 3 to the 4th times 4 to the 3rd squared, well, each one of them, it applies to each one of them. 3 to the 4 times 2 times 4 to the 3 times 2. So this would be 3 to the 8th times 4 to the 6th. And if they ask you to multiply it out, fine, use your calculator and multiply that out. On a scientific calculator, what you would do is the caret. So you would type in 3, that symbol, and 8, and equals. For the 4, it would be 4 caret 6 and equals. Next is quotient of powers. Quotient meaning division. So we're going to divide two powers. So let's say 7 to the 8th divided by 7 to the 5th. Now in order to figure out this one, 1, 2, 3, 4, 5, 6, 7, 8. 7 multiplied by itself 8 times on top and by 5 times on the bottom. 1, 2, 4, 5. Well, we know that 7 divided by 7 is 1. So those would cancel and give us 1. 2, 3 pairs, 4 pairs, and 5 pairs. Those all equal 1. So on the top, we've got 1 times 1 times 1 times 1 times 1 times 7 times 7 times 7. On the bottom, it's just 1 times 1 times 1 times 1 times 1. So this equals 7 cubed. Again, what we want to do is look at the 8 and the 5, and how does that become a 3? Well, you may have guessed it already. If we are going to divide powers, if they have the same base again, then you subtract their exponents. So again, they have to have the same base. So again, if we had something like 4 to the 6th divided by 3 squared, that's just what it is, or you can multiply it out, but you cannot subtract those exponents. Now, what about the 0 power? 8 to the 0 power. I'm just going to tell you what it equals, and maybe you can figure out why. You might be thinking, well, 8 to the 0 power would make more sense if it were 0. But no, that's 8 times 0. 8 to the 0 power is 1. So notice it's still under the title of Quotient of Powers. It's because maybe it came from 8 to the 13th power over 8 to the 13th power, because that would equal 8 to the 13 minus 13, which equals 8 to the 0. And you can see that whatever 8 to the 13 is, well, it's still 8 to the 13 on the bottom. So whatever that value is, it's being divided by itself, which should equal 1. That should make sense. So it's really kind of cool. So like if we had negative 27 to the 0 power, that's still 1. What if we had negative 4 to the 0 power? Hopefully this one didn't trick you and that you got that would be negative 1. Notice that the base is only the 4. It's not in parentheses. So we want the opposite of 4 to the 0. 4 to the 0 is 1, and the opposite of that is negative 1. Well, so far we've only been talking about exponents that are whole numbers, 0 and positive numbers, but our title is integer exponents. So what do we do with a negative? So for instance, 2 to the negative 3. What do you think? Just like on the last one when we were trying to figure out what to do with the 0 power, maybe think about how could it have become negative 3? Well, quite possibly it could have been 2 to the 4 over 2 to the 7, right? Because that would equal 2 to the 4 minus 7, which equals 2 to the negative 3. So really, 2 to the negative 3 just equals 1 over 2 cubed. And if we're going to simplify that farther, that would be 1 over 8. Ooh, make sure you don't put 6 on that. Students really want to do that, but it's 2 times 2, which is 4, times 2, which is 8. So what if we had 1 over 3 to the negative 2? What would we do with that one? Well, you could, if you wanted to, change 1 to a power of 3. What would that be? 3 to the 0, right? Over 3 to the negative 2. So this would be 3 to the 0 minus negative 2. Which, of course, minus a negative is plus a positive, which is 3 squared. So something that we notice is anytime the exponent is negative, it really just means that the base is in the wrong place. Notice that 2 to the negative 3 is equal to 1 over 2 to the 3. And that 1 over 3 to the negative 2 is equal to 3 squared. So anytime I see a negative exponent, that just means that the base is in the wrong place. If it's in the denominator, it needs to be in the numerator. And if it's in the numerator, because of course we can put that over 1, then that just means it needs to be in the denominator. So let's try a couple of these. If you want to, you can pause it and try it yourself and then check with me. But this would be 9 to the, if you want to write it on there, 1 times 3. So I'm showing a middle step that a lot of people will skip over, times g to the 2 times 3, because remember, a power to a power, times f also to the 1 times 3. Well, this equals 9 cubed g to the 6th f cubed. And you'll have to read the directions. A lot of times they'll want you to multiply out that integer, so 9 cubed. So another way to write this one would be 729 g to the 6 f cubed. On the bottom, I like to break these up. Kind of like just look at 12 over 4 times a to the 5th over a times b over b cubed. And that's the way I'll show my work. 12 fourths times a to the 5th over a to the 1st if I want to help myself, right? And show my work a little bit more. B to the 1st over b cubed. Now don't get confused with this 12 divided by 4. That's just division. Don't do any kind of subtracting. Sometimes, we forget what we're doing here. This is just 3 times a to the 5th minus 1 times b to the 1 minus 3, which would equal 3 a to the 4th, b to the negative 2. And usually they don't want you to leave your answer with a negative exponent, so we would simplify that to 3a to the 4th over b squared. Last thing I want to talk about is 0 to the 0 power. What do you think that is? Well, according to our rule, that would be 1, but it's not. Because that would mean that it was like 0 to the 4th over 0 to the 4th. And that, my friends, is division by 0. So just like with all things, division by 0, 0 to the 0 power is undefined.